Learn VR/MR. Come to the Spatial XR community.
Now I will open Unity to demonstrate how to use XR Interaction Toolkit and Unity's input system to process XR input. We need to note here that XR Interaction Toolkit and Input System are two independent systems. L'Input System is the new version of the input system of the Unity game engine. It can be used to process input from different platforms, not only processing input from XR devices, but also processing input from devices such as computers and mobile phones. XR Interaction Toolkit is specifically suitable for the development of interactive functions for XR applications. We obtained device input through Unity's input system. Then the XR Interaction Toolkit processes this input to realize the interaction in the XR application. If I now want to implement a function of pressing the grab button of the controller to grab an object in the virtual world, I need to define an action called grab in Unity's input system, and then bind the grab action to the input of pressing the grab button of the controller. Then when we press the grab button of the controller, the input system will detect this input and regard the grab action as occurring. Then the XR Interaction Toolkit will handle the grab interaction. For example, when the controller approaches an object and triggers the grab action, the XR Interaction Toolkit will handle the interaction of the controller grabbing the object. This is the connection between the XR Interaction Toolkit and the input system. The core is an input configuration file. When we import the XR Interaction Toolkit, we will import a sample package called Starter Assets. In this sample package, an official input configuration file has been provided for us. We can find the location of the Starter Assets sample package. It is in the Samples folder in the project. Then it is here. We can see a file with this icon here. Its name is XRI Default Input Actions. Its type is Input Action Asset. It is an input configuration file in the input system. We can double-click this file to open it. The window that pops up now is the interface in this input configuration file. Let's take a look at what's in this window. The official input configuration file has configured some commonly used mapping relationships between actions and inputs. This interface is divided into three areas from left to right. Let's look at the leftmost column first. It's called Action Maps. And each row in it is equivalent to an action input mapping set called Input Action Map. The binding relationship between actions and inputs recorded in each action input mapping set will be displayed in the middle actions area. You can see in this middle area that different actions are recorded here. Now we can expand one of the actions. For example, I now select the select action. After expanding it, we can see that it has the next level. The next level of the action records the input bound to this action. For example, the grip button left hand XR controller is equivalent to the grab button on the left controller. We bind this input to the select action. When I press the grab button on the left controller, this input will be detected by the input system. And then the select action defined here will be triggered. Because we may define different types of input and action binding relationships in the input configuration file, we can logically classify the mapping of these different actions and inputs. This classification is represented by the Input Action Map Action Input mapping set on the far left. With this input mapping set, different actions can be better managed. For example, the XRL left interaction defined by the official here is mainly used to store some action and input mapping related to left-hand interaction. For example, this XRI right locomotion records the action and input mapping related to the right hand and movement. The actions recorded in each action input mapping set and the inputs bound to it are displayed in the actions window in the middle. Then let's look at the window on the far right. When we select an action, the window on the right will become Action Properties. It is the property panel of this action. When we select a bound input, the window on the right will become Binding Properties. It will display some information bound to this action. Let me first introduce some parameters on the Action Attribute panel. The most important one is the action type. We can see that there are 3 types to choose from, namely value, button, and pass-through. When we move the mouse cursor to the action type parameter, we can see the official English description of this action type. Now let's briefly introduce the differences between these 3 action types. First, the button type has only 2 states, pressed and not pressed. We usually use the button type to determine whether a certain button is pressed. Then the value type, which can represent continuous state changes. We can generally use it to represent buttons with key travel. For example, I can use the value type to determine the degree to which the trigger button of the controller is pressed. When the trigger button of the controller is not pressed, it will have a default value of 0. If the trigger button of the controller is gradually pressed and finally pressed to the bottom, the value recorded by this value type will gradually increase to 1. If we release the trigger button of the controller, the value of this value type will gradually decrease from 1 to 0. We can also use this value type to represent the degree to which the joystick of the controller is pushed. In many VR games, we need to push the joystick button of the controller to control the movement of the character in the VR world. We need to know in which direction the character will move, so we need to know the position of the joystick and its rotation range. The position of the joystick rotation will be represented by a 2-dimensional vector. This 2-dimensional item will act on the movement of the character to control the movement of the character on the horizontal plane. Finally, the pass-through type, like the value type, can be used for continuous state changes. However, there are still some subtle differences between it and the value type. I will give a specific example to illustrate. I will now define an action and bind this action to the trigger button of the controller. Just like the activate value action defined in the input configuration file. We can see that this action is bound to the trigger button of the controller to record the digital changes of the trigger button of the controller. The input of the button will have a default value. For the trigger button of the controller, its default value is 0, which means that the trigger button of the controller is not pressed or the trigger button is completely released. When we press the trigger button of the controller, the value of this button will begin to change. The action bound to the key input will be triggered only when the value of the key changes. This means that every time the value of the key changes, the action bound to it will also be triggered. The value of the trigger key will change during the process of the trigger key being pressed to the bottom. For the value type and the pass-through type, their effects are the same in this process. The action bound to the key input will be triggered once every time the value of the key changes. However, in the process of a key being pressed to the bottom and then released, the difference between the value type and the pass-through type will be reflected. When we completely release the trigger key, the value of the trigger key will return to its default value of 0. We said before that the action bound to the key input will be triggered when the value of the key changes. However, there is a special case for the value type. That is, when the value of the key returns to the default value, the action bound to the input will not be triggered. If I now want to continuously output the value of the trigger key to indicate the degree of the trigger key being pressed, that is, to output the value of the trigger key when the action bound to the trigger key is triggered. Because the action is triggered, it means that the value of the trigger key has changed. If we press the trigger key to the bottom and then gradually release it, the value type action will not output 0 at the moment of complete release. Because this value type action will not be triggered when the key value returns to the default value. The value type action will not output the default value of the key 0. If we change this action type to pass-through, when the key value returns to the default value, it can output the default value of the key. This is one of the differences between the value type and the pass-through type. That is, when the key value returns to the default value, the value type bound action will not be triggered, while the pass-through type bound action will be triggered. Another difference between the value type and the pass-through type is how they handle conflicting inputs. If an action is bound to multiple inputs, and these inputs are triggered at the same time, for the value type, it will switch to the most important input. When an input value is greater than the input that is currently driving the action, the input with a larger value will take over the right to drive the action. When the pass-through class faces multiple inputs, it will only let the most recent input drive the action. For example, the action I defined now binds both the trigger button of the left controller and the trigger button of the right controller. When I press the trigger button of the left controller to the bottom, I try to press the trigger button of the right controller. If I press the trigger button of the right controller halfway, the value of the trigger button of the right controller is about 0.5. Because the half button of the controller is pressed to the bottom, the value of the trigger button of the left controller is 1. If I set the action type to value, then during the process of pressing the trigger button of the left controller, because the value of the trigger button of the left controller changes, this action can be triggered normally. When the trigger button of the left controller has been pressed to the bottom, press the trigger button of the right controller. Although the value of the trigger button of the right controller has changed, the trigger button of the right controller is only half pressed, and its value is 0.5, which is less than the value of the trigger button of the left controller one. At this time, the trigger button of the left controller still retains the driving power of the action. Because the value of the trigger button of the right controller is smaller than that of the trigger button of the left controller, and the trigger button of the right controller is triggered later, the trigger button of the right controller will not take over the driving power of this action. Even if the value of the trigger button of the right controller changes, it will not trigger this action. Only when we release the trigger button of the left controller will the trigger button of the right controller take over the driving power of this action. This is another feature of the value type. For the pass-through type, it only pays attention to the most recent input. When we press the trigger button of the left controller, the trigger button of the left controller will take over the driving power of this action. At this time, if we press the trigger button of the right controller, the driving power will be transferred to the trigger button of the right controller. The above is the difference between pass-through and value types. I will give a brief introduction to other parameters on the action property panel. Let's look at the control type first. If the action type is selected as value or password, it will display the control type. If we select button, it will not display the control type. The control type mainly classifies the pass-through and value types in more detail. We can see that the Activate Value action is defined in the official input configuration file. It binds the trigger button of the controller to indicate the degree to which the trigger button of the controller is pressed. Because the trigger button value of the controller changes between 0 and 1, it may have a decimal number, that is, a decimal between 0 and 1. In this case, we can choose axis. The axis type can be used to represent decimal values of float type. Among the control types listed here, there is another commonly used type, which is vector 2. We can now switch to the XRI left locomotion action input mapping set. Click the move action. We can see that this action type is also value and the control type becomes vector 2. This move action can be used to turn the joystick to control the continuous movement of the character in VR. So this action needs to get the input value of the joystick. The value of the remote sensing is not a single value, but is represented by two numbers. We will explain it in detail later when we introduce the movement function. Now you just need to know that the value of the joystick needs to be represented by a value on the x-axis and a value on the y-axis. So it needs to use a two-dimensional vector to represent the value of the joystick. Therefore, this control type is to select vector 2 to represent the two-dimensional vector. There are also interactions parameters and processors parameters on this action properties panel. These two parameters are generally related to specific inputs. Now we can click on the input under this action to take a look at the binding properties panel on this input and introduce some of its parameters. First of all, the most important thing is this path. We can specify where the input bound to the action comes from on this path. Now the input bound to this action is trigger, which is equivalent to the trigger button of the controller. Path limits the trigger button on which specific controller. We can see that it limits the trigger button on the left controller. Grip button is the input bound to the select action. It limits the grab button on the left controller. Let's take a look at other bound inputs. This input under the move action. It is bound to the joystick on the right controller. It also limits the value of the joystick on the right controller on this path. Okay, these actions and inputs bound in the official input configuration file are often used. If we want to customize the input of a button, we need to create an action first, and then set the path of the input bound to this action to set where the action input comes from. We will introduce this knowledge point in more detail in the next class. Now we just need to understand what the parameters here are. Then we will go back to the binding properties panel to introduce the interactions and processors here. Interactions limits the input type in more detail. I can click the plus sign on the right side of interactions. We can see that different input types are listed here. For example, the hold type represents a long press. Multi-tap represents multiple clicks. Note that the options displayed under the interactions list will change according to the control type of the action properties. For example, the control type of this action is now axis, and we can see these options under interaction. Now let's find another action. For example, the control type of this move action is vector 2. We click on the input it is bound to. Click the plus sign under interactions. You can see that the options under the interactions list have changed compared to the previous list. It has an additional sector, interaction is often related to the function of the joystick of the controller. It is often used to determine the direction of the joystick push. I now click on the teleport mode action. This action is mainly related to the function of teleportation. Then we click on the input it is bound to. We can see that the interactions are set in this Binding Properties panel. It adds a sector here and selects north and directions. I will explain with the help of a few pictures. Because the joystick moves within a circular range. Then we can imagine it as a circle with a center at the dot and a radius of 1 in the XY coordinate system. The joystick will rotate within the range of this circle, and the value of the joystick will also change accordingly within this circular range. It is represented by a value on the x-axis and a value on the y-axis. Then the direction of this sector is represented by north up, south down, west left, and east right. Let's go back to this picture. We can see that north is up, south down, west left, and east right. If the direction of the sector is selected as north, that corresponds to the following picture. The red sector area represents the north of the sector. If our joystick is pushed forward, it is equivalent to pushing towards the north of the sector. So we set the direction of this sector to north in Unity, and the input of the ARM joystick pushing forward can be detected. When using the teleport function, we usually push the ARM joystick forward to activate the teleport function. Finally, let's look at the process parameter. It can process the received input and return a new data. Let's now look at the input bound under this move action. It sets the processor's parameter. We can click the plus sign here. We can see that processes provide several options. It adds the stick dead zone option here. You can see that a minimum and maximum value are set here. When we click default, we can manually change this value. Because the current binding receives a two-dimensional vector data from the joystick, when the value of this vector is less than the minimum value, the result will be regarded as vector 0. And when the size of this vector is greater than the maximum value, the size of this vector will be normalized to 1. If the minimum-maximum values are set, when the joystick is about to return to the origin, the joystick value is set to the default value at the origin. When the joystick is about to be pushed to the bottom, the joystick value will be set to the maximum value when it is pushed to the bottom. The stick dead zone in processors is to set an error range for remote sensing. That's almost the end of our introduction in this lesson. If you want to have a deeper understanding of the input system, you can check the official documentation of the input system. The official documentation has a very detailed introduction to various parameters. In this lesson, I just gave a preliminary introduction to some common parameters in this input configuration file. You just only need to know how to use it. To summarize, in the input system, first, we need to create an input configuration file, which is the input action asset file. Then, in this input configuration file, we need to create an action input mapping set, which is the input action map. Then, in the corresponding action input mapping set, first create an action in this mapping set to classify these actions. After creating the action, we need to bind the corresponding key input to this action. That is, to create a specific binding at the next level of this action. Then set the path on the binding properties panel to set which key this action is bound to. Then we can set other properties of the action. The most common one is to set the action type, which has 3 types to choose from. You can also set some properties of the input to which the action is bound. In this lesson, I introduced the page layout and some commonly used parameter settings in this input configuration file. In the next lesson, I will introduce how to customize some key inputs in this input configuration file and how to associate this input configuration file in Unity code and get the actions defined in the input configuration file. When the system detects the input bound to this action, it will trigger this action. We need to execute the corresponding code logic when the action is triggered. So stay tuned to the next course.